up to multiplying and dividing is usually what they showed in 20-2. Which we got them to show it. It's not even in the curriculum, but it's beneficial for you in 30-2, so they were nice enough to show it there. So, equivalent rationals and non-permissible values. A rational expression is just one where it has like a fraction with some variables. So an example could be like x plus 3 over x minus 4. It's an expression because it's not equal to something. A rational equation would be like that equal to 7. A rational expression is just like the fraction, because expressions don't have equal signs. So, all right. Non-permissible values are the values that would make the denominator be 0. Because our denominator is not allowed to equal 0, correct? So anytime you have a variable in the denominator, you have a non-permissible value. Or you have to at least check for non-permissible values. Values that, if it was that, would make my denominator be 0, right? So if I looked at a basic one, like this, 7 over x plus 3. What couldn't x be? Because if it was that, my denominator would be 0. I plug something in for this. What can't I plug in because my denominator would be 0? Negative 3, correct? So my non-permissible value is x can't equal negative 3. That's it. The easiest way to do them, if you can't imagine that, and sometimes they get harder, is you take the denominator, you say x plus 3. Hey, just so you know, x plus 3, it can't equal 0. Because if x plus 3 equaled 0, I would have a denominator that's 0, right? And then you just solve for your x. Subtract 3. X can't equal negative 3. So you can do it that way too, by actually physically solving it. Right? Setting your denominator not equal to 0. Now, if only it were always just that easy. So often we have to do a bit of steps before we can. So here, if ever I ask you for MPVs, the first thing you need to do is you go to your denominator, because all we care about is the denominator, right? Can the numerator equal 0? Yeah, you can go 0 divided by anything. That's just 0. So if your numerator is equal to 0, your answer is equal to 0. If your denominator is equal to 0, your calculator gets mad at you, because it can't happen. Okay? So what we have to do is we have to go to the denominators, if only if it asks for just MPVs. I don't care what the numerator is. It could have a unicorn on top of it. I don't really care, because I don't care what the numerator is at all if they only ask for non-permissible values, right? So I go to my denominator. I make sure that I factor it. So that's GCF, difference of squares. And then I take each factor and I set it equal to 0 and solve. So let's look at example 1. Example 1 says, consider the rational expression x plus 1, which I don't care because it's just going to ask me for non-permissible values, over 5x squared minus 5x. Now that denominator isn't in perfect form. I need to see if I can take out GCFs or difference of squares at first. So the numerator stays x plus 1. And the denominator, can I take out a GCF? That's what I was asked for first. That's why we practiced what we did yesterday. What can we take out? 5x. And we take out a 5x. We're left with 5x squared divided by 5x is x. Minus 5x divided by 5x is minus 1. Now, I know that this is silly. What I'm going to do next, it looks silly. But trust me, if you do it, you will do better on the unit test. I learned this many years into teaching it when I was like, ooh, I really should have done this earlier. The 5 and the x that you take out in front are both multiplied, correct? Yes? When things are multiplied, are they like stuck together? Or is 5 just multiplied by x, and I could write it as x multiplied by 5, right? Like, they're not stuck together. They're just side by side, kind of floating beside each other, correct? So how we can show that is whenever I take a GCF out and it's a monomial or one term without a plus sign, I just do this. I put them in their own brackets. Now I know it looks silly, but the people who adapt to this sooner do way better on this unit. The people who take that little monomial that's out front and write it separately will do better in this unit. I know they will. Because they won't cross off stuff they're not allowed to. Okay? So now that I've taken out GCF, I don't have any difference of squares to do, correct? Now every single thing that's in a bracket is a factor. Okay, so the 5 is a factor, x is a factor, x minus 1 is a factor. True statement? So what I do once I've taken out GCFs or difference of squares, I just take each bracket and set it not equal to 0. Because if 5 became 0, 0 times anything cancels. If x became 0, 0 times anything cancels. If x minus 1, that bracket became 0, 0 times anything cancels, correct? So I'm going to go 5 can't equal 0. And that's just a true statement, correct? That's just, yes, that's accurate. But that's not a non-permissible value because 5 can equal 0. 5 is 5, right? So this doesn't actually create me an NPV. It's just a true statement. So I always show it, but then I just cross it off because it doesn't matter. Okay? Then I take x and say it can't equal 0. Okay, well that's done. And then I take x minus 1 can't equal 0. So x can't equal 1. Now the catch is I can check them. If I plug 0 back into my denominator, 5 times 0 times negative 1 is 0, right? So this would create a 0 in my denominator, so I know I'm right. Then I try 1. 5 times 1 times 1 minus 1, what's 1 minus 1? 0. What's 5 times 1 times 0? 0. So my whole denominator becomes 0 again, correct? And I can't have it be 0. So those are my two NPVs. Oops, hit my board. All right. So now that's the non-permissible values. Now it says state the restrictions. Why I wrote these as two separate questions? To prove a point. Restrictions and non-permissible values mean the exact same thing. So my restrictions are x can't equal 0, comma 1. I can just put them together if I want. This and this, interchangeable. Same word. I know it's not the exact same word, but it means the exact same thing. So if they ask for restrictions on the variable, well, your restrictions on the variable would be x can equal 0 and 1, right? Your non-permissible values are x equals 0 and 1. Those are the ones you can't actually have. So when they ask for non-permissible values, they can say x equals 0 and 1. They don't have to say not equal to because that's what the restrictions are. X equals 0 and 1 are the ones that are out. Those are the non-permissible values. Those are the ones we're not allowed to permit. So if you say non-permissible values are x equals 0 and 1, that's a true statement. You don't need to have the not equal to because you're saying the non-permissible values, the ones I'm not allowed to have, are 0 and 1. That's why they can put it equal to. All right. So here we have to determine the non-permissible values restrictions for the following. So I go to my denominator and I say, can I take out a GCF or difference of squares? No. Now this is another thing I make everyone do that they don't like to do, but it'll make you get everything right so you can either adapt to my way or not. Those are your options. But the a and the 1 have a minus sign in between. Okay? Paying attention? When they have a minus sign in between or a plus sign in between, it actually sews together the terms on both sides of it. So I have an a, I have a 1 with a minus sign in between, correct? So it's as if the a and the 1 are sewn together by the minus sign. How do we represent that? By putting brackets around the whole thing. So this gets a bracket and this gets a bracket because the a and the 1 are sewn together by the minus sign. So if there's a minus sign in the middle or a plus sign in the middle, make sure you put brackets. Okay? So I put brackets around that. Nothing I can do to it. I can't GCF it. I can't difference of squares it. So I just set it not equal to 0. So a can't equal, sorry, I got ahead of myself. A minus 1 can't equal 0. So a can't equal 1. Now in your notes, if you want to write NPVs, you can because you're allowed to short form in your notes. But on a test, you'll always write non-permissible values. An exam is never a time to short form. Okay? We do not short form on exams. In your notes, could you write NPVs? Sure. There are your notes. Okay, B. I have 4 over 2k squared minus k. Because I'm only asking for restrictions, I'm only looking at the denominator. Can I do anything to that denominator? You take out a? Someone said it. A k. So I get a k. Then I get a bracket. 2k squared divided by k is 2k. Minus k divided by k, minus 1. Remember when I take a GCF out of 2 terms, in the brackets I should still have 2 terms. True statement? This k sitting in front can go in its own bracket. How many NPVs should I get? How many brackets are there with variables in them? There's 2 brackets with variables in them, correct? So I should get 2 NPVs. Every bracket that has a variable in it results in a non-permissible value. All right? That's why I bracket everything. All the brackets with a variable in it result in their own NPV. So I take k, can't equal 0. That one's done. And then I get tk minus 1, can't equal 0. Add the 1 over. 2k, I think it said tk. 2k can't equal 1. Divide by 2. K can't equal a half. So the non-permissible values are k can't equal 0 and a half. Then we're going to flip over. Whoa, what does this one say? Your turn. What do you think it is? Your turn. Okay, cool. Try it out. All right. So this first one, we have negative 2x minus 4 on the bottom. We can just rewrite our top, but when we go to rewrite these, you have to have equal signs running down the left-hand side. So whenever your expression, if you're rewriting it again, it's this equals this equals this. You're literally just changing the expression into some other form, but it's still the same expression. So you should have equal signs running down the left-hand side whenever you are doing expressions. If there's an equation, it already has an equal sign. You just put the equal sign where it is in the equation. You just follow that down. But if you're given a question like this and there's no equal sign, the equal sign runs down the left-hand side. So make sure you have it there. So here we have 2x minus 4. I'm not worrying about the numerator because it's only asking for the non-permissible values. Here I can take out a negative 2. When I take a negative 2 out, negative 2x divided by negative 2 is x. Negative 4 divided by negative 2 is positive 2. And then I can put the 2 in its own bracket. So currently I have 2 brackets. True statement? How many of them have variables? In the 2, how many of them have variables? How many of them have letters? One of the brackets has a letter in it, correct? Yeah? So how many NPVs are you going to get? 1. You get the number of NPVs that is equal to the number of brackets that have a variable. Okay? Because I take negative 2 can't equal 0, well, that's just a true statement. So I put a line through it. And then I do x plus 2 can't equal 0. X can't equal negative 2. There's my non-permissible value. So the number of brackets you have that contain a variable in them is the number of non-permissible values you will have. So if I look at B, I leave the top B the same. What can I do to the bottom? Yeah, I can square root it. It's a difference of squares. There's 2 terms with a subtraction sign. Whenever I have 2 terms with a subtraction, I'll always check for difference of squares. So the square root of a squared is a. The square root of 81 is 9. So I'm going to get a plus 9 and a minus 9. How many brackets do I have in the denominator? 2. How many of them have variables in them? 2. How many NPVs am I going to get? 2. The number of variables with brackets with variables gets me an NPV, right? So I'm going to have a plus 9 can't equal 0. A can't equal negative 9. And I'm going to have a minus 9 can't equal 0. A can't equal positive 9. Now they'll often write these together like this. A can't equal plus or minus 9, like this. What can I do to C? I'm going to leave the top, leave the numerator. What can I do to the bottom? Take out a p. Then I get 4p squared, take out a p is 4p, minus p divided by p is 1. Then this p in front goes in its own brackets. How many brackets do I have? 2. How many have variables? 2. How many NPVs am I going to get? 2. So I do p can't equal 0. That one's done. And then I do 4p minus 1 can't equal 0. Add the 1. 4p can't equal 1. Divide by 4. P can't equal a quarter. And then I often put them together. I'm going to go p can't equal 0 or a quarter. D, the trick question. D, I can take a 2 out of the denominator, and I'm left with x squared plus 4, which some people think is a difference of squares. It's actually an addition of squares. Right? You can't factor an addition of squares. There's also nothing that I can fill in that will make it be a 0. So 2 won't give me an NPV, it doesn't have a variable. X squared plus 4, I have to say, okay, what could I fill in for this x that when I square it, gets this to go away, and I get a 0. So I have to fill something in for x that will become negative 4 plus 4 equals 0, right? I need this somehow to be negative 4. People tell me negative 2. Negative 2 squared is 4. Is there anything I can fill into this x that will ever create this to be 0? No. When you have an addition of squares, you have no non-permissible values. In the textbook, I'm going to have some questions for you to do. I'll take pictures of the textbook and post it as well. I'll go that route. The textbook questions are: number 3 and 9A. I'll take a picture of it and post it.